Welcome viewers, in this video we will see the solved problem based on the DC transient response of RC circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, problem based on the transient DC transient response of RC circuit, resistor and capacitor. We'll see the statement of the problem. A resistance R and a 2 microfarad capacitor are connected in series across a 200 volt direct supply. Across the capacitor is a neon lamp that strikes at 120 voltage. So R and C is connected in series. R value is not given. C value is 2 microfarad connected across 200 voltage, and capacitor having the neon lamp that with the voltage of 120. There are two questions available. Calculate the R to make the lamp strike 5 seconds after the switch has been closed. We need to find the R value when the switch is strike after 5 seconds. 5 seconds after the switch has been closed. Second question, R value is given. R is 5 mega ohm. How long it will take the lamp to strike? Right? Here we need to find the time. We need to calculate the time. R value is given. First question, R value we need to find. The time is given 5 seconds. Now we'll see the RC circuit, the TC transient of RC circuit general equation. From that we can calculate these values one by one. So the case 1 will first we'll consider the case 1. T is 5 seconds. We need to find the R value. So EC equal to E of 1 minus e power minus T1 divided by lambda 1. So this is the DC transient response of a RC circuit. Separate video available how we are getting this equation. So here the EC is 120 voltage, neon lamp. Total voltage applied across R and C is 200 ohm. T1 is given 5 seconds. Lambda 1 is nothing but C into R1, constant. That is a constant. In that C value is known, R1 we need to find. Now substitute all the values so that EC is 120, E is 200 of 1 minus e power T1 is 5 minus 5 divided by lambda 1. Right. Now bring this 200 in the denominator and go for simplification. So 0.6 equal to 1 minus e power minus 5 by lambda. Right. Now bring this e this side, 0.6 that side, so that we can go for the further simplification. So brought to this side, so the negative become positive. E power minus 5 by lambda 1 equal to 1 minus this plus 0.6 will goes to that side is minus 0.6. So totally 1 minus 0.6 is 0.4. E power minus 5 by lambda 1 equal to 0.4. Now we need to find the lambda 1 value. From that we need to find R value. So here e power is there. So we'll take the log on both the side. By taking log on both the side, we can easily identify the value of lambda 1. So take log on both the side with base e. Log with base e. Log e power minus 5 by lambda 1 with base e equal to log 0.4 with base e. So this e power minus 5 by lambda will come to this side, right? So e power will come minus 5 by lambda 1 log e with base e equal to the value of log 0.4 with base e is minus 0.916. We know that log e with base e is 1. The value is 1. So we have only minus 5 by lambda 1 equal to minus 0.916. So minus available on both the sides. So bring this lambda 1 that side, 0.916 this side. So 5 divided by 0.916 equal to lambda 1. That is 5.46. 5 divided by 0.9 is 5.46 equal to lambda 1. That is lambda 1 equal to 5.46. So from that we can find R value. This lambda 1 is nothing but C into R1. So that R1 equal to lambda 1 by C. Lambda 1 what we calculated 5.46 divided by C value is 2 microfarad. 2 into 10 to the power minus 6. So that is nothing but 2.73 into 10 to the power 6 ohm. That is 2.73 mega ohm. Right? Otherwise 2.73 into 10 to the power 6 ohm. So now we calculated the R value for a time given 5 seconds. The next question, the R value is given 5 mega ohm. For that we need to find the time taken. So in the second case, R2 value is given 5 mega ohm. We know that lambda 2 equal to C into R2, that is equal to C value is 2 microfarad, 2 into 10 to the power minus 6 into 5 mega ohm, 5 into 10 to the power 6. So this both got cancelled, 2 into 5, 10 seconds, right? So the lambda 2 is 10 seconds. But we know that e power minus 5 by lambda 1 equal to 0.4. So that is already given. So that is from the previous equation. So in the above equation we can replace lambda 1 by lambda 2, t1 by t2, so that we can get the time for second, so that we can substitute this time. E power minus t2 by lambda 2 equal to 0.4. So this is the equation already available in previous case. In that we are replacing this lambda 1 by lambda 2, this minus 5 by t2, so that we can able to find the value of t2. Now again we need to take the log on both the sides, so that we can able to find the t2 value. Lambda 2 value is known, only t2 we need to find. So log e power minus t2 by lambda 2 with base e equal to log 0.4 base e, right? So what happened, this power will come in the front side. Minus t2 divided by lambda 2 log e with base e. The value of this log 0.4 is minus 0.916, right? So log e with base e is 1, we know that. So that minus available on both the sides, so it becomes positive. t2 divided by lambda 2 equal to 0.916. Bring this lambda to that side. So t2 equal to 0.916 into lambda 2. Lambda 2 we know that 10. That's what we calculated, 10 seconds. So 0.916 into 10 is 9.16. So the t2 equal to nearly it is 9.2 seconds. So with R equal to 5 mega ohm, the time taken by the neon lamp is 9.2 seconds. So in this video we discuss about the DC transient response of RC circuit. Solved problem 3. So R and C is connected in series across the voltage and neon lamp is connected. In the first case, the 5 seconds time is given. For that we calculated the R value. In second case, the R value is given. For that we calculated the time taken. It is 9.2 seconds. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.